Hi class, here's the homework for Monday, February 10th. We just started Chapter 7, Ratios and Proportions. So number 1, we're going to write the ratio in simplified form. 28 elementary schools to 16 middle schools. So I'm going to put 28 on the top and I'm going to put 16 on the bottom. That's the ratio. You could write it like this as well. Either way, we're going to need to simplify, which means divide by the common factors. So there's a common factor here between 28 and 16. I happen to know 4 is a common factor, so I'll divide this by 4 and this by 4, and that's 7 over 4. So 7 elementary schools to 4 middle schools. So when you write the ratio, you need to be careful that you simplify it. Okay, number 3. 18 buses to 36 cars. 18 buses to 36 cars. Now, if you don't know a common factor in there, you could just start dividing by 2. Divided by 2, divided by 2, that's 9 over 18. Well, I know 9 goes into both of those. This is divided by 9, and this is divided by 9. So 1 over 2. 1 bus for every 2 cars. Sometimes it's helpful to put those labels on there. There's 1 bus for every 2 cars. The hockey team played 82 regular season games last year. If they won 44 games, what is the ratio of wins to losses? So that means wins is going to go on top, right? And losses is going to go on the bottom. So they won 44 games. How many losses do they have? So if you wrote 82 over 44, that is not right. We're comparing wins, which was 44, to how many they lost. So 82 minus 44 is equal to 38. So they lost 38 games. So 44 to 38 is what your ratio should be, wins to losses. Now we can divide these by 2 to simplify the fractions. So I'm going to divide this by 2 and divide this by 2 because they're both even. That's 22 over 19. And I think that's as far as you can go. 19 is a prime number. Okay. Let's look at number 7. Oh, by the way, the vowels are A, E, I, O, U, sometimes Y, but we don't even have a Y in that word. So count how many vowels, and the vowels go on top, right? You're going to put the vowels on top. So you have a certain number of vowels, and you have a certain number of letters. Number 7. Myra is playing a board game. Now we're going to make a prediction, so we're going to use a proportion. After 12 turns, she has landed on the blue space 3 times. So for every 12 turns, she lands on the blue space. So I'm going to just go ahead and call that 12 turns and 3 blue spaces. Okay, for every 12 turns. Well, if she takes 100 turns, how many times will she land on a blue space? Remember, these units have to match. So I'm going to put 100 turns up here. And we're going to solve for how many times. So if for every 12 times she hits 3 blues, then how many will she hit for 100 times? And this is the proportion. Okay, I can rewrite it with just numbers if that helps. I saw some of you simplify that, and that's fine. But right now we can just leave it like this, and now we can cross multiply. 12x equals 300. And then to solve, we divide 300 by 12, so that's 25. So x will be 25. 25 blue spaces. For 12 turns, she'll land on 3, but if she goes 100 turns, then she'll land on it 25, most likely. Okay, and number 8, you're looking at the ratio of male to female. So male will go on top until you learn how to get better at setting these up. So male to female is 3 to 4. So 3 goes on top and 4 goes on the bottom. If the number of male students in the club is 18, okay, so we put 3 is male on the top. So if we're going to set up our proportion, it's 3 males to 4 females. If there's 18 males, that's going to go on the top, and you're going to solve. Okay, so cross multiply and solve. Now solve it. Okay. Number 9 is the ratio of the measure of two complementary angles is 7 to 8. What is the measure of the smaller angle? So to solve these extended ratio type problems, we're going to take 7 and put an x there, and we're going to take the 8 and put an x after it. Okay? This represents the measure of one angle, and this represents the measure of another angle. So we're going to take 7x plus 8x, and that's going to equal, well, the ratio of the measures is 7 to 8. What is the measure of the small? Okay, wait. The ratio of the measures of two complementary angles is 7 to 8. So these two angles have to add up to 90 degrees. That's the definition of complementary. So if the ratio is 7 to 8, I taught you to put the x after the 7 and the x after the 8 and add them together. That's 15x equals 90. Divide by 15 on both sides, and we get x equals 8. No, it's 90 divided by 6. X equals 6. Now, x equals 6. So what is the measure of the smallest angle? Well, if x equals 6, this is going to be the smaller angle. 7 times 6 is going to be smaller than 8 times 6. So we just take that 7 and multiply it times the 6, and we get 42 degrees. So the smaller angle is 42 degrees. Number 10. Two supplementary angles are in a 7 to 2 ratio. Find the angles. Well, we're going to change that to 7x to 2x. Well, if I take those two angles and I add them up, they have to equal 180 because they're supplementary. So that's 9x equals 180. Divide both sides by 9, and we get x equals 20. So we solved for x. Now we're going to take that x and put it in here. 7 times 20 equals 140. So one of the angles is 140 degrees, and the other angle is going to be 2 times 20, which is just 40 degrees. And notice, if you add 140 plus 40, you get 180. Two supplementary angles are in an 8 to 1 ratio. So we have 8x to 1x. And they're supplementary angles. So we're going to do this top part first. So 8x, this one angle plus this other angle, have to equal 180 degrees because they're supplementary. So 8x plus 1x, this is 9x equals 180. Divide by 9, x equals 20. Find the complement of the smallest angle. Okay, well, the smallest angle is going to be this one. And that's just 1 times x, so that's just 20. So the small angle is 20. Well, the complement to that will be 90 minus 20. And that's 70. Okay, number 13. And if you need help to do number 12, watch how I do 13. The ratio of the measures of the three angles in a triangle is 10 to 3 to 7. So we're going to write that as 10x to 3x to 7x, so that we can write an equation. We're going to take each of these angles and add them up. 10x plus 3x plus 7x, and that's going to equal 180 because they are the three angles of a triangle. So that's 13 plus 7, that's 20x equals 180, and x equals 9. So by setting these ratios all added up equal to 180, then we get x equals 9. So if we want to find the measure of the largest angle, that's going to be this one right here. It's represented by 10x. So 10 times x is 10 times 9, which is 90. So the largest angle is 90 degrees. And you'll do the same thing for number 12 that you were doing for number 13. But notice we're just putting an x after the ratio number, and then we're making an equation. Okay, so 14 is just a little bit trickier. The ratio of the measure, okay, so here's an isosceles triangle. And it says the ratio of the vertex angle to the base angle is 8 to 5. So let's call this is the vertex angle. Let's call that 8x. And the base angle is 5x. Because the ratio is 8 to 5. Well, we need this third angle. Well, if these are congruent, then opposite angles are congruent. These base angles are congruent. So now we have the measure of each angle. So we take 8x plus 5x plus 5x equals 180. And go ahead and solve that. Solve that for x. Then you're going to put that value in here to find the vertex angle. Okay, so now we're looking at the back side. And let's call this 14b since I have two 14s. Okay, so this is 14 on the back side. The ratio of the measures of the sides of a triangle is 4 to 7 to 5. If the perimeter of the triangle is 128 yards, find the length of the longest side. So let's take this extended ratio again and let's rewrite it as this. So we can write an equation like this. So 4x plus 7x plus 5x has to equal the perimeter. This is the length of one side of the triangle. Remember, the perimeter is going to be equal to this side plus this side plus this side. You're going to add up all the sides, and that's going to be the perimeter. And the perimeter here is 128. So if you add up the length of all three sides, it should equal 128. So then let's add this up. This is 11x, that's plus 5, that's 16x equals 128. I'm going to take 128 and divide it by 16, and I get x equals 8. So now I'm asked to find the length of the longest side. Well, the longest side is going to be this one, right? It's 7 times 8. 7 times 8 will be the length of the longest side. And you're going to do the same exact thing with 15. You're going to write 21x plus 8x plus 14x equals 215. Okay. To solve proportions, we use the cross product property, which means I could make like a butterfly here, and I can take the top of this fraction times the bottom of that one. That's 3 times 40, and that's going to equal x times 5, or 5x. So I multiply these two together, and that's going to be equal to these two together. That's 120 equals 5x. Divide by 5, x equals 24. And we've solved. Okay, we're going to do it again on 16. We're going to cross multiply. So that's 7 times, now this is a quantity, so we need to put it in parentheses. That's x plus 1. And that's going to equal 5 times 3. So 7 times x plus 1 equals 5 times 3, so that's our equation with the cross products. Now I'm going to distribute. 7 times x is, I'll just draw a little arrow here, 7 times x and 7 times 1. 7x plus 7 equals 15. And we're going to solve this equation after we distribute it. So we'll subtract 7 from both sides, and we get 7x equals 8. Now, to solve for x, we're going to divide both sides by 7, and we get x equals 8 over 7, and so we got a fraction. Sometimes some of these will be fractions, and that's my answer. Now, for 17, you're going to do the same thing. You're going to multiply this times this, and this times this, and distribute and solve. So I'll set it up. It's 6 here times x minus 2. I like to put the single number in front and then the quantity second so I can distribute from left to right. And over here I'm going to do the same thing. I'm going to take the 3 and multiply that by the quantity of x plus 4. I like to have it so that the numbers are in front. Okay, so then I'm going to distribute and solve. And I'm going to let you do that one. Okay, distribute and solve. Okay, number 18. We're going to multiply that pair. and that's going to equal this pair. So you're going to finish solving this. X times x is not 2x, it's x squared, and that equals 36. Now to solve this equation, it's kind of like when we're using the Pythagorean and we have to take the square root of both sides. Take the square root of this side and the square root of this side, and we're going to get x on this side equals. Now because this is an x and this is an equation, we're not going to just take the positive root of 6. We are also going to take the negative root, negative 6. 6 times 6 equals 36, and negative 6 times negative 6 also equals 36. So we're going to take both of those answers. So you're going to get 2 answers here when you take the square root of both sides. We don't know what quantities we're talking about. We're not talking about measures necessarily or lengths of sides like we were with the Pythagorean, so we need to include the negative answers. Okay, so 19, you're going to solve that one again by multiplying, cross-multiplying. So that's 5 times x minus 1 equals 3 times x plus 4. And I'll go ahead and do this one, and if you needed help with that one, then you can watch this one. Okay, I'm going to distribute. So that's 5x, and then 5 times a negative 1, that's minus 5. And 3 times x, that's 3x, and then 3 times 4 is plus 12. And we subtract 3x from both sides. That's 2x minus 5 equals 12. And then we can keep solving. Add 5 to both sides. And we get 2x equals 17. Divide both sides by 2, and we get x equals 17 over 2. Okay, here we're asked, remember we're solving for x, so we're going to do the cross multiplying. So 5a equals x times b. Well, if I'm solving for x, I need to get x by itself. This is being multiplied times b, so to get rid of this b on this side, I'll just divide by b. So I get 5a over b equals x, and I'm done. Okay, 21. Now I did one like this in class, and I'm going to go ahead and do it here too because it is a little bit more involved. I'm not going to do 22. This one is optional, and it requires multiplying binomials together, factoring, and solving. So I don't expect you to do this one. If you want me to show you, I can show you later. All right, so 21, I want you to try it though if you think you know how to do it. All right, so 21, we're going to take these two and multiply them together. And the way I showed you in class was I took x plus 1 times x plus 1, and that equals 3 times 3, which is 9, right? And then I said, let's write this as x plus 1 squared, just like if you were multiplying x times x, it's x squared. We're going to take this whole quantity and this whole quantity and square it. Okay. Now, we can solve this equation by taking the square root of both sides. And on this side we get x plus 1. And on this side we get plus or minus 3. So we have two cases here. We have the case where x plus 1 equals a positive 3, and we have the case where x plus 1 equals the negative 3. So if we subtract 1 from both sides, we're going to get x equals 2 here. Right? And if we subtract 1 here, we're going to get x equals negative 4. So those are your two answers. But the trick was to notice that x plus 1 times x plus 1 is the same thing as x plus 1 squared. Take the square root of both sides and you get x plus 1 equals plus or minus 3. And then set x plus 1 equal to 3 and x plus 1 equal to negative 3. What is true if things are in a 1-to-1 ratio? They are equal. The ratio of A to B to C is 1/2 to 1/3 to 1/4. 1/2 to 1/3 to 1/4. Well, if we can multiply every term by x like we did on the other side, or divide every term by a number to reduce, we can certainly multiply each of these numbers. If we want to write it in terms of whole numbers, then we want to get rid of the fraction. Well, a common denominator between 2 and 3 and 4 is 12. 2 goes into 12, 3 goes into 12, and 4 goes into 12. So if I multiply 1/2 times 12, and 1/3 times 12, and 1/4 times 12, I'll get some whole numbers here. So let's see, let me darken in this ratio here. I'm taking 1/2 and multiplying it times 12. 1/2 of 12 is 6. 1/3 times 12, that's going to be 4. Because that's 12 over 3. And this is going to be 12 over 4, so that's 3. And I've just rewritten that ratio into whole numbers by multiplying every single one of these fractions by 12. I multiplied it by the common denominator of 12. You could have multiplied by 24 as well, and then just simplified afterwards. Okay, the challenge. Okay, 4 numbers that add to the sum of the interior angles of a hexagon. So we have 4 numbers that add to the sum of the interior angles of a hexagon. Well, the interior angles of a hexagon are going to be 6 minus 2 times 180, and that's 4 times 180, and that's 720. So 4 numbers are going to add to 720. The first 2 numbers are in a 1-to-1 ratio, and the last 2 numbers are but the last number is double the first number. So if this is 1 and this is 1, then this is 2 and this is 2. The first 2 are in a 1-to-1 ratio. The second 2 are in a 1-to-1 ratio, but this one is twice this one. Or this one. This one is twice this one. So that's what the extended ratio looks like. So I can write an x in here. X, x, 2x, 2x, and write an equation. All of these angles, x, or all these numbers, x plus 2x plus 2x has to equal 720. That's 4x, 6x equals 720. X equals 120. So that means our ratio is going to be 120 to 120 to 240 to 240. If the last number, okay, what is the difference between the sum of the first number and the last number and the sum of the second number and the third number? Well, the first number and the last number are 360, and the sum of the second and the third number are also 360. So their difference is 0. And that's it. I hope you had some good learning, and I'll see you in class on Wednesday.